Hey everyone, if you haven't worked with local LLM agents in a serious project, or even if you haven't even started, this video can help you get up to speed. When you want to build a local LLM agent, it's not just about changing syntax and using one class instead of another one, but you will face an entire set of new challenges in which you should tackle. Otherwise, your project is gonna be so fragile and sometimes it works, sometimes not. So in this video, we'll start from scratch and build an agentic AI project with a local LLM agent, and we'll see what challenges await us along the way, and we'll figure out how to address those challenges together. So without further ado, let's start. So here's what we're gonna do. We'll build an agentic AI project in which a local LLM gets a PDF and tries to summarize the content of that PDF. Of course, content summarization is a very basic task and a very well-known problem in LLMs and in natural language processing, or NLP. And I believe LLMs are quite effective at it nowadays. But I want to just twist it a little bit to make it more challenging for the LLM, and we'll see how good the local LLMs are in following our instructions. Of course, this is a very slight twist. Instead of asking it to summarize the whole PDF, I want to say before that, just check how many pages does that PDF have, and at the very beginning of your summarization, also include that piece of information. So instead of just summarizing the content, start with, okay, this document has, for example, 8 pages, and then here's the summary. So let's see if the local LLMs nowadays are effective in that or not. So just like the previous videos, we'll be working with AutoGen. It is really easy to implement an agent with local LLM in AutoGen. We'll see it momentarily. And for the local LLM, we'll use Ollama. If you're not familiar with Ollama, my previous video is a brief introduction to Ollama and how to use local LLMs with Ollama. So you're more than welcome to take a look at that video if you feel like it's necessary. But if you're familiar, or if you know the general concept of what Ollama does and how can we use a local LLM with Ollama, you're good to go for this video. So let me start a new file. I'll call it agent.py, and I'll be working with AutoGen. So from AutoGen agent_chat.agents import assistant agent, just like previous videos. And if you remember, in previous videos we were using AutoGen x.models.openai, and we would have used OpenAI chat completion client. Well, for Ollama models, we can say from AutoGen x.models.ollama import Ollama chat completion client. Okay, so, and we'll also import async IO, just like what we've done so far in previous videos. So let me define a main coroutine, async def main, and I want to show you how to work with this local LLM without it being an agent, just how to work with the LLM alone. So model will be Ollama chat completion client, and I can specify the model name. And as you remember from the previous video on Ollama, let's visit Ollama website for a second. We can go to their GitHub. So a very basic model to start working with Ollama is Llama 3.2. It's a famous model from Meta. So let's see how it works. So my model will be Llama 3.2, and if I want to call my model, it has a create method, so I can say response will be await model.create, and I should pass a sequence of LLM messages like user message in AutoGen. So I can say from AutoGen core dot models, I guess, import user message. So I can say, okay, this is a user message coming from user. The source is user. And the content is, yeah, hello, how are you? I just want to see its response. Python agent.py. Oh, I forgot to create the event loop and call this. So if name equals main, async.io.run main. So it creates a new event loop and calls this coroutine. And by the way, you should make sure that Ollama is running. If you can see its icon, like this one, then it means Ollama is running and you can call the models. And of course, since you're using a local LLM, it might take a little bit longer than an API-based, cloud-based LLM such as ChatGPT. So this is a slight disadvantage of using a local LLM. Sometimes they take longer than an API-based model, but at the same time, you have privacy and everything is running on your own machine, and you're not worried about your data being trained on in the future. And also, as another advantage, you will not be paying for APIs. And you see, we have the answer. I'm just a language model, so I don't have emotions or feelings like humans do. Okay, fine. So this is how you can directly interact with a LLM, with a local LLM in AutoGen. But of course, we're gonna create an agent with this local LLM, and we'll interact with that one too. So this is our assistant agent. So I can say the agent will be an assistant agent. Let's choose a name for that. I will just call it summarizer. And we should specify a system message. I would say you are a summarizer agent. And you will receive a PDF file and summarize its content in a concise manner. Yes. So here's the scenario so far. We will pass a PDF file to the agent, and the agent needs to, initially it needs to find out how many pages does that PDF file have, and then it should read that PDF file and summarize its content. So, and let's make it there, and okay. Here's what you need to do. One, so let's assume we have a function to figure out how many pages does a PDF have. So we'll build that tool right now, momentarily, and then we will have another function, another tool to read the content of the PDF file. So initially, check the number of pages in the PDF file using the appropriate tool. 2, and for 2 I would say no. For 2 I would say use the appropriate tool to read the content of the PDF file, and 3, summarize the content of the PDF file in a concise manner. Yeah. At the beginning of your summarization, include the number of pages in the PDF file. Fair enough. Okay, so we have this system message now. Now it's time to specify the model client. Model client will be this model. And now it's time to develop the tools. We'll be using the PyPDF library in Python. So let me show you. It's really easy to use PyPDF. Yeah, PyPDF 2. Okay. Let me find a simple example of how to work with that. Yeah, extract text from a PDF. It's this simple. From PyPDF, import PDF reader. You'll create a PDF reader object and you will pass the path to the PDF file. And then you can easily, for example, extract text, find out how many pages it has, and so on and so forth. So from PyPDF, import PDF reader, and this will be our function, def count PDF pages, okay. And this is the PDF file path. It should be a string, and in the end it will return an integer. And this is a documentation for that. Counts the number of pages in a PDF file, and now we will create a reader object, a PDF reader of PDF file path, and we can just say return len of reader.pages. And we'll also need to, okay, before this, let's just make sure if the model is capable enough to call this tool. So I will, for now, let me just remove those steps. I just want to see if the model can call that tool. So I also need to pass the tools, and right now we have just one tool, count PDF pages. And as you remember from the previous videos, whenever we want the model to call a tool, it is usually beneficiary to also pass the reflect on tool use flag as true. This way, once the model calls a tool and has the answer from the tool, it will process it and also generate some message based on that tool response. Otherwise, we will just see what the tool has returned. And to be able to show the model's response in the terminal, I can use the console object in AutoGen. From AutoGen agent chat.ui import console. And okay, now I can easily say await console.console, and I should pass a stream to the console, so I can call agent.runStream, and I need to provide the task or the input to the agent. And just for test, I've included a test.pdf file. It's a one-page PDF of a Docker cheat sheet. You can see it's some regular commands in Docker. So I can say summarize test.pdf file, something like this. And let's run the code. Okay, you see it called the count PDF pages. It got 1, and now it says the test.pdf file has 1 page. Good. So far, so good. And now it's time to implement another tool for reading the content of the PDF. I will call it read PDF file. And again, it gets a PDF file pass as a string, and it will return another string, which is the content of the PDF file. And okay, we'll instantiate a PDF reader object, and initially the text will be null or an empty string, and we will go over the pages and we'll extract the text of each page and add it to our text variable. And in the end, we will return text.strip. And why do we use the .strip part? Because it might have some extra spaces at the end of the PDF. For example, they might have one extra blank page. We don't want to include that and make our string longer. So we use the .strip method. It's a method in strings in Python to remove extra spaces. Okay. Now we'll also pass the read PDF file as well, and I will bring back the step 2 and 3 of our system message. Let's see if it works now as well. You see, the problem is emerging. So at the beginning, it is using the read PDF file. Although I've told it explicitly that at your first stage, you need to check the number of pages. But it has, I guess, we cannot be sure about what is happening under the hood with these LLMs. There is no theoretical approach, at least so far. But we can guess, and I believe that, it is when it has a read the content part in its system message, it dominates the other parts, because I guess it has seen more data during its training about, reading something and, importing something rather than, counting the number of pages or, checking the number of pages of something. So since these are not very strong LLMs, very intelligent LLMs, they can just, easily get distracted when they see something that is more familiar to them. So, and it has also hallucinated. You can see the test.pdf file has 2 pages. It has just 1 page. We just saw it. You see, it's just 1 page. So the document provides an overview of Docker, a containerization platform. Okay, this part is fine. It has tried to summarize it a little bit, although I can say that the summarization is not effective because this file has lots of comments, but this is just a very brief introduction to the file, not a summarization. But it failed to fetch how many pages it has and include that in the summary correctly. So this is one problem with working with local LLMs. They're not really effective at following instructions. Of course, there are some local LLMs that are explicitly trained to follow instructions, with that single purpose. But others have been trained to follow instructions as well, but they're not that effective. So for example, here you can see Llama 3.2 isn't that effective when we have a tiny twist of a regular task. So what can we do? Well, we have several options to tackle this problem. One option is to be creative and, do some part ourselves instead of delegating it to the LLM. So we can just fetch the number of pages of that PDF file manually and include that in this read PDF file as well, and add it to the content at the beginning of the content. And my guess is that then the LLM will be able to, then we'll have just one tool. The LLM will use the correct tool, and it will hopefully come up with what we're looking for. But I don't want to do this way now, because I want to do it in a more agentic way. And we want to experience how to work with these local LLMs and these local LLM agents. So one other approach to tackle this problem is to try to modify this system message and do some prompt engineering things to make sure it knows how to behave. For example, we can change the way we're stating the steps, or we can include some examples, make it a one shot or a few shot. For example, say if the PDF is a.text, a.pdf, then you will need to call this function first, and then you will need to call that function next, and then you will need to summarize it, something like this. Maybe it works. I don't want to do that either, but I strongly encourage you to do that and drop a comment and tell me what happened. That would be awesome. Or even if you can push it to a GitHub repo and share the link so that the community can take a look at it and see what was the result, that will be awesome. But as a third way to tackle this problem, we can consider using some more intelligent LLMs. So I believe Llama is a little bit overrated because it's from Meta, and there are way better LLMs out there. So let's go and check other LLMs. So let's go to Ollama website. There's a models page. For example, you can see from the popular models, we have DeepSeek R1, and it has a variety of versions from 1.5 billion version to 671 billion per version. So let's try this 1.5 billion and see how it works. This is a lightweight version. And as you remember from the previous video, I can say Ollama run DeepSeek R1 1.5 billion. And if you haven't downloaded it and this is your first time working with this model, it can take a few minutes to pull it or download it to your machine, and then you're good to go and you can start chatting. So let's say, hey there. Hello, how can I assist you today? Good. Are you able to summarize content? Thinking. Yeah, this is a model with thinking capabilities. Okay, so the user just asked if I'm able to summarize. I need to figure out how best to respond. First off, I should acknowledge their questions since they're clearly asking for what I can do. I remember that I don't have access to external links or real-time data. I should make sure my response is encouraging and helpful. It is funny, it's somehow overthinking, but it's good. Letting them know I'll do whatever I can do for their content. It's also good to mention where they can find the actual summary. Okay. No, I don't have access to external links. Cool. And I can say bye to finish this conversation. It also has a 7 billion or 8 billion version as well. You can see the size of each version. I guess I also have the 8 billion version, so let's use the 8 billion version as well and see the differences. Okay, hey there. God, it started thinking from the very beginning. I like the 1.5 billion version better because header doesn't need this amount of thinking. The user just said header in a very casual and friendly tone. This seemed like an open-ended greeting without any specific request yet. Okay, first things first, this is clearly initiating a conversation rather than asking for help. The lowercase letters suggest they're comfortable being informal. Their choice of header makes me think they might be younger, since older generations tend to use more formal greetings. Or perhaps they just prefer casual texting style. Oh my god, this is huge overthinking for just 2 words. I should match their energy but stay slightly more polished. And it is going on and on. Okay, just reply back. And it is even thinking about the exclamation point here I have. Hey there, how can I help you today? It didn't need this much of thought. Okay. Can you summarize a text for me? Okay, the user just asked if I can summarize. They're friendly and casual with their greeting, but this feels like a straightforward functional request, probably not looking for small talk or deep analysis. They didn't specify what kind of text. Okay, that's enough. So let's see if we can use DeepSeek R1 for this. DeepSeek R1, I would go with 1.5 billion version. Python agent.py. Oh, the model does not support function calling. Okay, fair enough. So you see, this model doesn't support tool calling. So we have 2 ways. One way is to forget about this model and go and find another model. One other way is to use one of those solutions I already mentioned. For example, to do the reading manually ourselves and then include that in our prompt here, while we're trying to form this task variable to form the prompt to the agent. We can call this tool manually, this read PDF file and count PDF pages, and include them in our message. So that way our task variable would be, here's the content, and we have the whole content in the string, and then here's the number of pages, now summarize. And I'm quite sure it can handle that kind of input. But let's go and find another model. We want some models that have tools capability. Okay, Qwen 3 seems like a good candidate, and it was updated 1 week ago. It has both tools and thinking capabilities, so I guess this is a good model. And some variants, you can see Qwen 3, 0.6 billion, we have 1.7 billion, we have 8 billion, we have 4 billion, different versions. And of course, they usually have their benchmarks. Larger models with more parameters, of course they behave better, but at the same time they're much slower, especially if you're trying to run them locally on your own machine, and especially if you're trying to run them on a CPU. Okay, so I remember I had some versions of these models. Okay, I have Qwen 3 1.7 billion and Qwen 3 8 billion. Okay, so let's use the 1.7 or maybe the 8 billion. Let's start with 1.7 and see if it works. If not, we will migrate to the 8 billion. So now I will use, instead of model, instead of DeepSeek, I will use Qwen 3. What was it? Qwen 3 column 1.7 billion. Okay, this is the initial prompt. Summarize test.pdf file. Okay, you see it started calling the right tool, count PDF pages, and it got 1. So far so good. And we can also see its thinking process. Okay, the user wants me to summarize. Let me start with figuring out how to handle this. First, I need to check the number of pages. That's correct. User provided a tool, count PDF pages. Okay, so I should call that. Once I have the page count, I can proceed to read the actual content using this one. After obtaining the content, I'll need to generate a concise summary. This is good. So you see it has called the count PDF pages tool and it got 1, and now this is its reflection. We can see the thinking process, and this is the final answer. The PDF file contains 1 page. However, the actual content cannot be retrieved due to accessibility restrictions. Okay, so one problem we have right now, and this problem is not specialized for local LLMs. Had we used cloud-based and API-based LLMs as well, we would have faced this problem again. So once you have a single agent and you're using the run stream method of that single agent, it only generates 1 response, 1 turn. So if you have a tool, it can call the tool, get the answer, and reflect on it, and that's all. But in our use case, we need to call 2 different tools and reflect on both of them, or even probably, have some more turns of messages as well. So in these use cases, we can create a team, but with only 1 agent, with that single agent. So just like what we've done in previous videos, we can create a round robin group chat, and for its participants, we can just pass 1 agent, this agent. So this way, this agent is gonna talk several times until we have a termination condition or the maximum number of terms is met. So let me also import the round robin group chat from AutoGen agent chat.teams. Import round robin group chat. And if you're not familiar with round robin group chat, our previous videos such as the debate between 2 agents or the programming, the code developer agents, those videos have round robin group chat. I explained it in more detail. Okay, so let's create a team now. I would say we have a round robin group chat, and the participants, of course, we have just 1 participant, the agent, and we can also specify a termination condition. For now, let's leave it, but we'll come back and make this work as well. And for maximum number of turns, for now, I would say 3 turns. And instead of calling runStream from agent, I will call the team.runStream. And let's run the code again. Okay, count PDF pages is called. This is correct. And now we're waiting for its reflection on this tool call. Okay, the PDF file contains one page with the text. This is a test PDF file. It contains some information about the summarization. Okay, this is a clear hallucination. The summary highlights that the file is a single page, okay, and the number of pages. So we see it couldn't call the right tool now. Let's change it to an 8 billion parameters. Of course, in this video, my purpose is to be more explorative and, check different models and try to see different behaviors of these local LLMs. But if you're really trying to implement a project like this one, a better solution might be to just modify the prompts and try to paraphrase it, include some examples in the prompts, and that might also work even more effectively than what we're doing right now. But here we're just trying to explore, different behaviors of these local LLMs. So let's see what the 8 billion version does. And while we're waiting for the LLM to respond, just as a side note, I'm sure we're all seeing it. There are many ways to tackle a challenge, to address a problem. Maybe I use one way to address that problem in this video, but as you're seeing it, there are many other ways as well. I strongly encourage you, go ahead and try to do it in different ways. And even better than that, drop a comment and tell us what you did and how it helped or it did not help. This way our community can just take a look at the comments and see many different solutions and what different people got from them. So this is a call to action. Please do it yourself. And this is also good for yourself as well, because if you really want to learn something effectively, watching is not enough. It might help a lot. It might be necessary sometimes, but it is never enough. You need to do it yourself if you really want to be sure that you've mastered all of it. So please go on and do it yourself and tell us about it. Okay, so it's taking a long time for Qwen 8 billion parameters to run on my machine. So let's go back to the 1.7 billion and try to come up with a solution to make that work. So let's read our system message again. You are a summarizer agent. You will receive a PDF file and summarize its content in a concise manner. And here's what you need to do, 3 steps. Check the number of pages using this tool, or maybe I can say it is doing this stage right, so let's not touch it. To use the appropriate tool to read the content of the PDF file, maybe I can say call the appropriate tool, maybe it helps. And 3, summarize the content of the after you have called the 2 tools, summarize and got their outputs. Summarize the content of the PDF file. At the beginning, include the number. Okay. Let's see if this helps. Okay, now you can see. The user wants me to summarize the content of test.pdf. Let me start by figuring out how to handle this. I need to check the number. And initially, oh, this is wrong. Initially, it called the read PDF file. And what is this? Oh, it has called both tools at once. Okay. Both the PDF, both the count PDF pages and read PDF file. This is good. So this is the result from one of the tools. And can we see the result? Yeah, this is the result from the count PDF pages. It's 1. And this is the result from this read PDF file. And this is exactly the content of that PDF file. Now it says, let's see, the user wants me to do this. Looking at the content, it's a CLI cheat sheet, correct. And the PDF contains a CLI cheat sheet for Docker. Okay. The document provides quick references for Docker, including commands for managing images, containers, and system resources. And pages 1. This is good enough. You know, this is way better than what we were experiencing. But let's see if I can also improve this. I don't want it to tell me about the number of pages in a separate message. So let's say after you've called the two models, the two tools, and got their output, summarize in a concise manner. At the beginning, include this one. For example, your summary should look like this. The PDF file has X pages. Here's the summary of its content. Okay, something like this. So let's run it again and see what happens. Okay, first it is calling the count PDF pages. It gets 1. So does it call the read PDF tool afterwards or not? Yeah, it is tricking us. The PDF file has 1 page. This is correct. Here's the summary. The file contains a single page with this and that. Okay. So this is not what I'm looking for. So let's elaborate on our example. For example, your summary, for example, if the user says summarize a.pdf, you should call, let me name the tool as well, count PDF pages and read PDF file tools to get the number of pages and the content, the PDF file respectively. Then use the outputs of these tools to create a summary like this. So in LLM research, this is called a one-shot prompt, a one-shot example. It means that you've included one example of the correct behavior. We can also have few-shot examples, and according to many researchers, few-shot prompts are proven to be more effective than one-shot prompts, but we'll try to make this work by one shot. Okay, now you can see this is better. It has called the count PDF pages and read PDF file. Here's the result from count PDF pages, and here's the result from the read PDF file tool. Now it should reflect on these two outputs. Okay, the PDF file has one page. Here is the summary. The text provides a CLI cheat sheet for building Docker. Yeah, this is exactly what I was looking for from the beginning. So now we have another problem. As you can see it, the response is correct, but the team went on and the agent produced some more messages afterwards. This is not good. This can lead to incorrect messages and incorrect responses. We want to terminate the chat while we're happy with it and we have our answers. So I should also import termination conditions from AutoGen agent chat.conditions import. As you remember from previous videos, in AutoGen we have a text mention termination, and what it does is that it watches for a single expression or a certain piece of text. For example, you can assign a keyword. You can say, okay, watch, and whenever the agent says terminate with capital letters or any other expression, terminate the conversation. Okay, so in this theme, I can also specify termination condition, and it will be a text mention termination. And what is the text? It is terminate. And I need to also mention this in my prompts as step 4. Once you have the summary, exactly say terminate. Okay, so I should say this is summary and then terminate in our example as well. So let's run this example again. Again, we can see the correct behavior. We have both of the tool calls, the page numbers, and reading the PDF. And now the agent is reflecting on these two tool calls. Okay, we can see the PDF file has one page. Here's the summary. This is good, but I can't see terminate. Maybe the next message will be terminate. Okay, here's the terminate, and we're done. So now we have a quite working project that uses a local LLM agent, and we've experienced from the beginning working with Llama. It wasn't quite effective at following our instructions. Then we changed to DeepSeek. It didn't have tool call capability. And then we changed to Qwen, the 1.7 billion version. The 8 billion didn't even run on my machine. I remember it ran several days ago, but I don't know, maybe my CPU was busier now, or maybe there was some other reason, I'm not sure. But it was taking a lot of time now, so I just interrupted it. And now it is working with Qwen 3 1.7 billion. And just one thing that it might occur to you, it didn't happen right now, but I face it in my own projects. Sometimes when you say, once you have done your job or you have the summary, exactly say terminate, it happens sometimes that even before finishing its job, it says, for example, now it's not time to say terminate, I should go on, but at that moment it has said terminate, and AutoGen will terminate the conversation. So this can be a very good exercise. I can leave it to you to figure it out, and you can answer in the comments. It has a very easy solution to use it, to solve it, to prevent this from happening. I can talk about it in my next video if I remember, but now I encourage you to think about it and leave your comments and tell me, how can we tackle this problem? How can we avoid, such situations that before finishing its job, it says, okay, now it's not time to say terminate, but well, then we terminate the conversation. So this is one good exercise and question for you. And other than that, let's just, for the sake of comparison, let's use ChatGPT like what we've done in previous videos and see how good that is. Of course, my guess is that this is not really a guess. I'm quite sure it will eat this one from AutoGen x.models.openai, import OpenAI chat completion client, and I have the API here. I can just read it. So instead of using Ollama chat completion, I will use OpenAI chat completion client, and for API key, open api.text.read.strip, and the model. For model, I will use GPT4-o. This isn't the most intelligent model of ChatGPT, but let's see how it behaves. Okay, you see, it's way faster because we're not doing the process. We're just calling the API, and OpenAI servers are doing the process for us. And there we are. We have the summarization that we were wishing for. But Let's also try one of the previous versions of our prompt. So let me just comment this one for now and add another system message. You are a summarizer agent. And well, previously we had these steps. Let me see. Previously we had these steps, I guess. Here's what you need to do. 1, check the number of pages. 2, call the appropriate tool. 3, instead of call, let's say use, because it was used before, as I remember. And it was harder for our models when this was used. After you've called the 2 tools, no, I don't say this, just summarize the content. And at the beginning, include the number. Okay, let's see how it does with this very short prompt. Oh, what happened? Oh, I need to insert a comma here. Okay. Summarize. It has called the 2 tools, you can see. And yes, the PDF contains only 1 page. Where was that? Yeah. It is a CLI and this and that. Oh, but I forgot to say, you need to say terminate in the end. Yeah. Once you have the summary, exactly say terminate. So let's run it once again. Okay, you see again correct tool calls and correct answer and terminate. So as you can see right now, the API-based, the cloud-based LLMs such as ChatGPT, they're far more intelligent than local LLMs, of course, than lightweight local LLMs. Maybe if we have used a larger version of a local LLM, like an 80 billion version or a 70 billion version or a 600 billion version, this might have worked just like what we saw for ChatGPT. But if you want to use some small, some lightweight local LLM agents, you might, face some challenges that you wouldn't have faced if you had worked with ChatGPT, for example, or Gemini. So we've seen the challenges. Well, you can choose to work with cloud-based LLMs, but at the same time, you will have some privacy concerns. You will never be sure that maybe your data will be trained on someday, or maybe there's even not those LLM providers, but somehow during the traffic, your data is lost or is not safe. But when you're working with a local LLM, you're always sure that everything is happening inside your machine, your data is safe. You can even work with that offline without any internet access. So, but at the same time, you have some challenges, which we saw some of them in this video. But of course, if you're a developer, I'm sure you can handle all of the challenges associated with these local LLM agents, and you can benefit from the privacy you get. So I didn't have any plan to record this video and the previous one on Ollama and local LLM agents, but about 2 weeks ago, Prashant, one of our dear friends, left a comment and asked me to record some videos on this topic, and I find that a very good topic to cover. So thank you, Prashant, and I hope you find this video useful. If you have any suggestions or cool ideas for the next videos, you're more than welcome to drop a comment, and if I find them interesting to myself, I will definitely record a video about them someday. In the next video, I'm going to talk about Model Context Protocols, or MCP, a very hot topic right now in the agentic world, and how they work and how to use them in AutoGen and how to build agents that can use MCP. So until the next video, take care.